Okay. Everybody excited? Opening day. Before I get started, I'm going to do a little small talk here just to kill a little time to make sure we have a chance for everyone to show up. How many folks have explored Docker, played with Docker, built a container image, anything like that? Show of hands. Okay, so about 30% of you or so. Great. That's really good because it gives me a level set. As I go through this presentation, I'm going to talk a little bit about just containers themselves, what they are, what makes them unique, and why they're advantageous for us to use them as network engineers. And then I'll go into a demo and talk a little bit about how I use them, mostly from an automation perspective. So, containerization of applications, talk how they build and how they work and things like that. So it is 2:30, so I'm going to go ahead and get started. Thank you, everyone, for showing up. My name is Quinn Snyder. I am a senior technical advocate with Cisco Learning and Certifications. And today we're going to be talking about Docker containers. Like I said earlier, show of hands, we had about 30% of you who are familiar with them. But before I get started, I want to take you down a little bit of a kind of an analogy here. And I want you to hold it in your minds as I go through this presentation. We've all probably traveled here or at least stayed in a hotel at some point. We know how a hotel works, right? It's a building with lots of rooms. In those rooms, we usually have a bed, a bathroom of some sort, maybe a mini fridge, curtains, place to store our clothes. But they're all pretty much the same, right? You bring what you need to function in that hotel room for the day, the week, whatever. And then you leave and someone else can come in. So they're very adaptable, very usable, but they're all about the same. And I want you to hold on to that because that's going to be very relevant as we talk about containers through this presentation. So on the agenda, we'll talk about containers and, more importantly, images. And we'll talk about how we actually build those. And I'm going to be a little bit pedantic. So for those of you who don't know me, I'm very clear when we talk about containers versus images. And we'll get into that difference there. We'll talk about how you make containers work for you. Like I said, this is for the network engineer. We're not usually developers. I had the luxury of coming from DevNet. So a lot of the developer-y stuff that goes on, I'm fairly familiar with. But it does create challenges. And even myself and Ralph around the back who developed CML, some of my developer friends, we understand that sometimes that barrier to entry for development can be really high because there's so many different tools that are out there. And how do you use them? How do you not blow up your system and have to reimage because you installed the wrong version of Python or the wrong version of Go or Ansible? So we'll talk about how you make them work for you as network engineers. I'll do a quick demo around how I use them, and that contains some sample code as well, so there'll be a QR code at the end. I'll let you know so you can take pictures of it to take you to the GitHub repo where all of this stuff sits, so you can use it after you leave this session. So we'll talk about containers. And if you haven't heard about containers, okay, actually, who has not heard about a container or Docker at all? Okay, perfect. So everyone's talking about containers, or at least been heard about them. And a container is a running set of packaged libraries and binaries. And I emphasize running. So if you have a container, you do a Docker PS, and it shows up, that's actually a container. If it's sitting at rest, it is just an image. That image can contain all the same stuff as the container, but that image does not have the in-memory data or some of the share mappings and things that can be associated with a container itself. The whole purpose of a Docker container is kind of like back in the early days we had Java, right? We had the Java virtual environment. We had this one binary blob that sat on our computers, whether they were Mac or Linux or Windows. We wrote a Java application that used that common set of binaries that we could then run, and it would be portable no matter what. If, like for the firewall folks out here, if you were using like ASDM, I know that had some challenges with it with the Java versions, but I could run ASDM on my Mac, I could run it on a Linux PC or on Windows, and it was the same look and feel because we're using those common sets of libraries and binaries. The same thing occurs with a Docker container. It's a common runtime environment. And most of the time, for like Windows and Macs, it's going to be a virtual machine that's kind of running in the background that provides that. Linux runs natively, but it's a standard runtime environment to abstract all of the complexities of the underlying operating system and provide something northbound into the container. That ensures portability. So like I said, I have some sample code at the end of this presentation. If you folks take my Docker files and build them locally in your system, you can use them no matter what system you're on. There are some caveats, and I'll get into those later. So they're completely portable. So it doesn't matter if I build on Mac and run on Linux, build on Windows, run on Mac, it's all the same. And they're very lightweight, generally. The bloat has gotten a little bit worse, but they're lightweight and generally faster to instantiate than a traditional VMs. Now, the reason being, and I'll get to a picture of that, is because we have abstracted all of that underlying OS stuff, and we're only bringing forth some specific APIs out of the kernel space. So in a traditional environment, we'll look over here first. I've used a type 1 hypervisor, so you're looking at like your VMware vSpheres, things like that. Slightly different for your type 2s like VirtualBox or VMware Fusion or things like that. We have our hardware and our hypervisor, and then we have that barrier of isolation. That isolation ensures that no VM can access the underlying kernel of the type 1 hypervisor, and we have separation east and west across those VMs. Yes, there's a little bit of hand waving there for like SRIOV, some GPU integrations, DPDK, where we have some very specific APIs that we can call northbound off of the hardware to ensure things like faster networking or GPU acceleration inside of the VM. But for all intents and purposes, let's call that isolation. Now, each of these VMs, we've all installed a VM before, we have to have an operating system. That operating system, Windows, Mac, kind of Linux. That operating system has all of those runtime environment binaries. So you've got all your system tools, your shell stuff, all inside of that OS component. Then on top of that, you install some kind of application. And generally, it's been like 1 or 2 applications per VM. So I've got my domain controller. I have this specific network monitoring app. Those all sit in VMs. So we have a lot of overhead between each of those different applications. So we're looking at 20, 30. If we're running a database, maybe that's 200 gigs. Like we've installed ICE on a VM before. Like our M&T nodes are like 500 gigs of space that are being used there. So we have a lot of resources that need to be allocated and a lot of contention if we do any oversubscription. Let's change that over to our Docker environment over here, or Podman or containerd.io. We still have that hardware, but on top of it, we have our operating system. We have to have some way to interact and run that. I know there's things like Rancher OS where we have just a baseband environment there, but we have some operating system running on top of that. Then we have specific socket access to the kernel space. So we do have some ability for those containers to reach down into the kernel and provide some similar attributes. So the common one right now would be like eBPF, the extended Berkeley packet filter. eBPF containers can actually run inside of that kernel space and provide some stuff up there to our container runtime. On top of that, we have that runtime. So if you've installed Docker on your system, that provides all of those tools, that common virtual machine to run these containers. And then when we build an image, all we're doing is we're referencing specific library files, maybe another image that we're pulling in from Docker Hub, and then we're installing our Python environment or maybe our Golang environment, and then we run our code to execute it. And I'll show all those steps there. So we have a lot lighter weight set of applications over there. The nice thing is that we can run many applications on top of a single Docker host. And that's how Kubernetes works. And if you want to know more about Kubernetes, I think Tuesday or Wednesday, I have a talk on Kubernetes where we get more into those details as well. But on top of the container runtime, we can have individual apps, so we can run multiple apps on top of that one container environment. So we have that lightweight instantiation. We don't have all that VMware bloat, or sorry, VM bloat. Could be VMware, could be something different. Now, there's a little bit of a challenge there. So as we run our containers, we do have to be more aware of our security posture. Because like I said before, when we ran VMs, they were isolated. We had that isolation layer over the top of the type 1 hypervisor. It is possible, if you write poor code or the application is not secured properly, that you can escape that container in its runtime environment, drop into the shell of your host system, and then run laterally across that. From a Docker standpoint, it's probably not going to happen very often, but there have been several breaches where Kubernetes has not been secured properly. They've gained access to a poorly written app that's a front end, some kind of web front end, had an exploit. They were able to take that exploit, escape out of that container, and move laterally across the entire deployment environment of that Kubernetes cluster, accessing backend databases, customer data, that kind of stuff. So we have some level of the security is always tantamount, but you have to be very careful when running a container because of that. Now, because we don't have that separation, that shared kernel space creates very quick instantiation time. So when I run a container, I can spin up that container in a matter of seconds. The build times for a container are maybe 35, 40 seconds. Large ones can take a couple of minutes. I'm running on an old Mac. Sometimes it can chug along a little bit, but it's much faster than installing a VM where you go click, 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 next. Yes, I need to do updates, all that kind of stuff. And because we don't have that overhead of the VM itself, if I have 5 Windows VMs, say 5 copies of Windows 10, Windows 11, whatever, Windows Server 20, whatever they're on now, I have 5 copies of that underlying Windows OS. So I'm taking 20, 30, 40 gigs of space just for the baseband operating system. I don't have that in containers because I'm using that virtual machine and having that shared access up northbound to each running container. So because of this, we have a lot more room for activities. We have a lot more space to run our containers. We can manage them a little bit better with things like Kubernetes or Docker Swarm before that, where we could very closely manage the underlying hardware and resources and gain the most usage out of that individual host because they were so lightweight. The one thing I wanted to touch on with the portability aspect that I mentioned earlier, Windows containers are a thing. So Windows IoT Core can be run as a container. Now remember where I said it has access to shared libraries northbound out of the operating system. If I build a Windows container, the reason that it can run Windows things on that IoT Core is because it's using the baseband Windows installation as well for those shared libraries northbound that are presented from the the container environment. So if you build an IoT Core container on your Windows system and hand it to me as a Mac user, I cannot run that. So not that there are many people running Windows containers. They are a thing, though. They are not as portable as everything else. So in this instance, as a Windows user, you don't have to raise your hand. You can run Windows containers as well as anything that I create. So in this one column, I will give a win to Windows users. That's all you're going to get. So we talk about building container images. If you look over here on this example over here, this is just a simple Docker file. I'm just building some simple stuff using some Python environments, and then installing like Viral Utils, which was an older version of the CML utils, and I think and Ansible 295. Did the volume drop? Did someone kill my mic? Can we? Yeah, if we can. Yeah, I will try to talk really, really, really loud because the show must go on. So with this environment, I have a couple of different layers inside of this Docker file. So it's a little hard to see, but everything over on the far right or far left side for you is in yellow. That's a Docker file verb. Every time we build something using a verb, that creates a Docker image or a Docker layer in that image. So if you've pulled a Docker image off of Docker Hub, you'll see it's pulling a lot of different layers, and you'll see progress bars and things like that. That's pulling each individual layer for that image. Each layer is determined by these verbs. So those verbs trigger actions. So some of them are just really simple, like this from says, there's already a container out there called, or an image out there called Python 376 Alpine 311. So that means I'm running Python version 376 on top of Alpine Linux version 311. So that from is just saying, take that base image, use that as the underlying foundation for this container, and then build stuff on top of it. Some of them are just data points like maintainer. Some of them are copy, where I'm moving stuff out of my operating system on my local host into the image itself. Some of them are run, which means I'm going to run the specific Linux command inside of that image to build or create that certain function. For those who have heard over and over again, as a network engineer, you have to learn Linux. More appropriately, you need to learn Bash. Bash is everywhere, especially, it's the language of the underlying internet, believe it or not. So learning Bash commands and being able to tie those together is very important for your continued success in cloud and other types of engineering as well. And if you want to learn more about that, I have a talk with Kareem Iskander. It's 5 tools to level up your automation game, and I go much deeper into Bash. So these runs create specific Bash commands inside of the container. Finally, at the bottom, I have this workdir and the command. So the workdir says basically a cd command, change to this directory, and then run this command, bin bash. So I'm just running a bash shell on top of this. So it's started up as a bash shell when I launch into that container. A couple of things that I don't like about using this example, but it illustrates. Early on in the early days of Docker, everyone said use Alpine as your base image because it was super tiny, very small. We're talking 50 megs per image as a start. The problem with that is that as we've gotten further up the chain and what we can do with our containers, there's problems that can happen within Alpine around Musl dev to create Python, like when we do a pip install and building those wheels from scratch. There's some problems that can come with that. There's problems with the cryptography package and a few other things. So generally speaking, you'll want to use something like Ubuntu or Fedora or things like that as the base image. And on Docker Hub, if you just search for Ubuntu, there's 1,000 of them. You can go right from the Ubuntu / whatever. It's all included there. If you're running Python, there's Python versions that are based on Ubuntu or other types of Linux as well. So if you just want to run a Python application, you just go to Python and they'll have an Ubuntu as well as Alpine and other things. And like I said, the bash scripting is all behind this. And the other important thing I want to talk about is order matters. So from a container, from an image perspective, this is one image. It will run top to bottom, build that image and stick it on my machine and say, now we can run it however you want. If I were to flip like this echo and this echo, even though it's the same stuff, it's a new image because that order has changed. So I'd have two images that are the exact same, but because I flipped the order in the Docker build, it sees them as two different images. The reason I mention that is because you want to, if you're going to iterate over an image, say we have a base image that we want to work from, and we're changing maybe the code we're running underneath it, we're changing a version of an application or Ansible or whatever else, you want to stick that towards the bottom, because if we change that, it can reuse all of this stuff up till where we've changed. Does that make sense? So the build times are much faster. For things like Ansible, pretty trivial because it'll take you 45 seconds. But if we're building large containers, we want to make sure that we align that order for the optimized build process. And then finally, to build it, we do a Docker build command. In this case, I'm tagging it with the -t, giving it my username, and then whatever I want to call it. In this case, DNE base 37 version 0.1. And then the part that most people miss is that period there at the end that says build from the local directory. If you forget that, it'll complain and say, nope, we don't know where we're going. And yes, it's all just bash, always has been. What's old is new. So any questions so far on the underlying foundations of containers? Perfect. I'm going to zoom through this next part because why do we care about containers as a network engineer? How many folks have tried to install Python on your laptop? How many people have had to re-image their laptop because they've installed the wrong Python version, or they've installed some pip stuff into system Python, not to a virtual environment, things like that? It happens. I've done it thousands of times. That's why I used to do all my development in a VM because I could just take a snapshot and revert. Now I let containers do the heavy lifting for me. So in this case, like I did for that other example where I was building Ansible inside of a container, I have a specific version of Python, a specific version of Ansible. I can build that together and I can do all of my automation and development stuff inside of that one container. If I need to up the level of or rev the version of Python or rev the version of Ansible, I change the directive in that Docker file, rebuild. Now I have a new environment. If I blow something up, all I do is nuke that running container and restart from the base image. So I now have an ephemeral development environment for my use case that I can run and operate on my laptop without having to worry about all the baggage of Python or all the virtuals, all the modules and things like that. And it provides me portability across environments. So I write a Docker file that has Python 3.10, Ansible 2.10. I give you that Docker file. You can build it locally on your machine. Now I have a thing here. It works on my machine is no longer a problem. It works on everybody's machines as long as you have Docker installed. And it's more convenient than VMs. The nice thing about VMs is they were kind of the gold standard for usability. People knew how to operate a VM. VirtualBox or VMware had a really easy GUI to use. So it was just start and then you drop into it. Running a container is a little bit harder, can be. So I use some stupid human tricks, throwback to the old David Letterman days, to interact with them. And I'll show you that, and that will also be inside of my repository that I hand out. The one thing that I will use is for the old neckbeards that have run Linux like I have for a long time. We used to do the make ins, or you would do a GCC build, then do a make, and then do a make install with GNU make. Make files were just the earliest form of automation that existed for the longest time. So the stupid human tricks that I'm looking for is actually with GNU make. So I use make files in a very, very ugly way. I've had many a distinguished engineer say, "Why are you doing it this way?" Because it works for me. It works on my machine. If you really want to know how to use make, it's really powerful. There's like a 700-page ebook link there. If you are really, really can't sleep at night, you can read that and teach me a few things. But we're just going to be using some phony targets, and we're not make installing here today. So demo, I will hold this up for a second. If you want to grab the code or save that, just take a picture of that for later on. And I will cruise through the next 10 minutes and show kind of what's going on. I will wait, grab some water while the phones are still up. Okay, I will put this. I will put this up after the session as well, or after I'm done, so we can move on to them. So I'm going to go through a demo here. All this code is available. You'll see it's the repo Cisco U1812. That was an old code, but rather than having a bunch of repositories in my GitHub, I just use the same one over and over again. So inside of here, I have a couple of different folders. Each of these folders contains a Docker file. So if I were to do a tree here, you can see that I have this Ansible 2.10. We have a Docker file. We have some folders that are there. For the Python, we have a Docker file and this version.py. So we have some folders that contain Docker files and some ancillary files associated with that. We also have this make file. So what I'll do here is look at the make file. Excuse me. This is what I was talking about by doing stupid human tricks. So make files, like I said, they were the earliest form of automation. It's just nested bash. Again, this is why bash is important. I've created some phony targets, which means it doesn't care about the status. So that's just kind of a GNU make idiosyncrasy because it was meant for building software, not for making images. And then I have these individual targets. So build Python 3.7, 3.10, 2.9, 2.10. Those are just commands that I can run make build Python 3.7, and it will execute the command underneath it. So Docker build T. So I'm tagging the build image, Python 3.7, and I'm building it inside of the respective directories there. That's all I'm doing. Down below that, I have Python 3.7, 3.10, Ansible 2.9, and 2.10. This is where I run those containers. So I've mapped each container to a build as well as a run command. This Python 3.7, in this case, I'm just doing a Docker run, which is how we run the image. We're running in interactive mode. The --rm says after I've killed the container, remove it from my running Docker registry on my local laptop. And then I'm doing some exports, so I make sure I have 256 colors inside of my terminal because I like colors. I don't like the black and white stuff. I have evolved a little bit. The final piece there is that I have this privileged, let's go to the end there. Well, a little too far. I have this -v. Now what this is doing is saying, this -v says create a volume inside of that Docker container. Docker volumes are just like virtual hard drives, if we want to think of it that way. But instead of actually just creating a standalone volume, map this folder, root my code, to a specific folder, in this case, my current working directory, Python 3.7, and then this is the container name. So basically saying, take a certain folder on my local system, map it to my running container, so I have access to the files back and forth. We'll see how that works out here. So just for grins and giggles, let's look at, I'm going to do a simpler one. So let's look at the Ansible 2.10 Docker file. I've run the Ansible 2.10 container from my Python 3.10. So I've done that from. So don't rebuild all the Python stuff that I've already created, but pull from that image, have a certain environment, the shell prefix there, copy in requirements.txt, do a pip install my certain collections, change to my code, and then run bash. So just a series of commands that I'm doing there. what I will do here is I will do make build Python 3.10. It's going to be very quick because I already have that container built, or should. Yep. So it's building. It's going through and it's gathering all those images or all those layers. So it's pulling certain things, building them out as needed, and it's actually downloading, which has me scared a little bit. But you can see it's doing the from. We're pulling some certain images there, and then as we scoot on here, you'll see it go through a bunch of different processes. I'm actually going to kill this right now, so we have time. But what I'm going to do is let's do a make Ansible 2.9. So instead of the Ansible 2.10, I've just got the Ansible 2.9. I've changed it so I now have my user at Ansible 2.9. And let's go ahead and clear this here so I am at the top. And you can see here, I have the Docker file, this Ansible folder, and the requirements.txt. That's mapped from that directory that I had before. You saw in the tree where I had those same files. So I've copied over and I've built the requirements. If I was to do a pip freeze here, you can see I've got Ansible 2.9.2.7 and all the associated stuff that goes with it. That was based out of my requirements.txt as based here. So it's copied that over. It's built that into the environment. If I go into the Ansible directory, I have these several YAML files as well as my config and my inventory. Let's cat the inventory. It's just pointing towards the DevNet's always-on sandboxes for iOS XE and NXOS, and assuming those haven't changed. And then finally, this 99test.yaml. I'm just gathering some iOS XE facts. So I can run Ansible playbook. And we'll do --v. We'll hope it works. We'll see if they've changed the passwords again. Anyway, what I'm showing here and what I'll do, yeah, it's going to fail because of the they've changed the interactive logins again. This will work if I had the right targets there. Trust me. Okay, yeah. So you can see it did work for the NXOS one. It's just the iOS XE one. So it reached out, grabbed those facts off of that device, and then was able to show them out as output here. I'm going to exit out of this. If I do a Docker PS, that $rm says I'm no longer running as an image. And if I do a ps-a, you can see it's not there, just the ones I've built. If I do a make Ansible 2.10, we'll see if this works. Yep. So you can see now Ansible 2.10, I've changed that because I built a separate container there. And if I do a pip freeze, you can see I've got Ansible 2.10.7. So I've built several containers with different versions of Ansible. If I were to do a Python version, you can see it's running Python 3.10.11. I didn't do that. It's actually 3.7 for the other version. So I've created different virtual environments to run these Ansible containers without having to affect the way that I run them on my system. And in fact, if I was to do exit here, and if I was to do a pip freeze, you can see I don't even have Ansible installed on my local system to show that I'm actually running that inside of my container. Or actually, I do have it installed. It's just not activated in this current environment. And the lights came on. So that's how we use containers to work for us as network engineers. We don't have to worry about all that baggage. We build it once. We run it once. If we make a mistake, we can kill it. We can move between different mapped volumes, so we can run our playbooks locally on our system and move them into the certain containers. So we can use that as our development environment without having any issues. I'll leave that up and go ahead. I think the other slides here are just continuing education. Follow me on Twitter at QSnyder. Cisco U Learning is behind us, and thank you. So I'll leave that up. Thank you so much for attending. If you have any questions about Docker containers, Kubernetes, I do a VI session as well that'll be here this week. Go ahead and find me. I'll be here all week. So thank you. Oh, last thing. If you look under your desk or under your chair, there will be a hanging penguin. Person with that hanging penguin, please bring it up, and you will win a Cisco U Stanley. Yeah, Stanley tumbler. They're real popular in the States.